When we talk about extending a wireless network, there's a couple of techniques that we can use. One of those we looked at earlier, and that was the idea of using an extended service set. Remember, that had independent connections to a distribution system. Another option is to use what we call repeaters. Repeaters are just access points, gang. Don't blow them out of proportion. They're just access points in the sense that they provide a point of wireless access to the infrastructure for the clients. But here's the rub. When we're talking about a repeater access point, I want you to notice what it doesn't have. Let's take a look here at this example. We see we have these repeaters scattered throughout our network, and what do they not have? They don't have their own independent wired connection to the physical switch, to the distribution system, right? This diagram does not look like this, where each of these repeaters has this. If we did that, we would have an extended service set configuration, and we would need to set up these 4 different access points at different channels to not overlap, so on and so forth. Instead, we have repeaters. And so the repeaters are actually a pure wireless to wireless communication that's going on between our different devices so that a client can essentially jump here on the caboose of this repeater train and then go through this train and eventually get out to the wired network, right? That's the idea. So it's a wireless to wireless to wireless to wired connection. And that's very different than just everyone connecting to their local wireless and then jumping up to the wired network as quickly as possible. So there's pros and cons to this. The pro of this is that, again, these are easy to configure. I can line these up, each with their antenna in a workplace, hang them from the rafters, and I need to provide power, but I don't have to provide wired networking in order for them to get connected. I don't have to be hooking RJ45s into their ports because they're going to use wireless communication to connect to the next repeater in the chain in order to convey that information. Now, it is still, again, it's designed to be dual half duplex. And what do we mean by that? Well, there's 2 main channels that communication occurs at with wireless networks. We see the 2.4 gigahertz channel used by some systems and the 5 gigahertz channel used by others. What we see here is that there will be communication at one frequency range used by the devices, the end devices, to hook up to that system. So 2.4 being used by the clients to gain access to the repeater. It doesn't have to work this way. There are other flavors of this, but one way to isolate this is for the repeater-to-repeater communication, kind of working through the system itself, is done on this backhaul that operates at a different gigahertz range. Again, if we can have newer implementations that use all 5 gigahertz, like 802.11ac, that's fine. Or that can use the alternate frequency for what's necessary. A lot of different things we can do. But the point being, we differentiate between the client access and the repeater-to-repeater access. The overlap here is 50%. So notice as we have these different access points, certainly we do have the ability for a client to connect and then walk over here, and they can roam just like an extended service set. The difference is we're using one channel. Okay, this is one channel of operation. We're all operating at the exact same frequency. And essentially, we're forcing all this traffic to eventually get funneled through this root access point, the access point that actually has a connection to the physical network. So we're not really increasing the number of clients that we can serve. When I think about an infrastructure mode ESS environment, if I could support easily, let's say, 60 devices off of this access point, I could support another 60 off of this access point as they work their way up to the switch. But if I'm working with repeaters, then essentially it's 60 available to the root that are now able to go farther away because I'm using repeaters. So in the sense, they are less effective, which makes sense. They don't have the benefit of their own dedicated connection to the wired network. They suffer because of that. However, their advantage is freedom. They are not having to be wired to the physical network. They're autonomous in that sense and able to move there. So yeah, that's a repeater, all right? And most of our access points, gang, are going to allow us to be able to move a particular device from being a traditional access point to being a repeater. Like they'll have a toggle switch to choose, which basically says, oh, I get it. I don't connect up to an access point. I need to connect to another repeater. The root device here is a full-fledged access point because, of course, you can see it is connected to the wired network. It's going to be kind of the host that everything is working its way toward. Again, mention that 50% overlap. Just in contrast, when we're talking about an infrastructure mode extended service end, the percent of overlap is more like 15 to 25% overlap is needed. Not that much as we roam from one to the other. Whereas with a repeater, we need a greater percentage of overlap as we work at the exact same channel connecting through the repeaters. One set of rules defined and all these other devices inheriting those rules essentially from the root, and this is still essentially just one large basic service set. So a simpler configuration in many cases.